Let us see how to find the square root of any given complex number. Suppose we have the complex number a plus ib, whose square root we have to find. Now let's assume that the square root of this complex number is, say, x plus iy. So basically we have to find the values of x and y. Now to find x and y, first what do is we square the both sides. So therefore we have a plus ib is nothing but the square of x plus iy, which gives us x square plus 2ixy, and you have I square y square. So therefore we have a plus ib is equal to, now x square is real and I square y square, which is nothing but minus y square, because I square is minus 1. So collecting the real parts, you have x square minus y square, and the remaining term is imaginary, in which we have I into 2xy. So here we have a plus ib equal to x square minus y square plus I into 2xy. Now we have already seen that when two complex numbers are same, it means their real parts must be same and their imaginary parts also must be same. So therefore this implies that x square minus y square must be equal to a and 2xy must be equal to b. So here we see that we have two equations in x and y, and on solving these two equations we have to obtain the values of x and y, and which gives us the answer of square root of a complex number. Now it's important to note that whenever we obtain the solutions of these two equations simultaneously, we have to make sure that whatever values we have got of x and y, all the possible pairs, they must satisfy these two equations. Let's see one example to illustrate how to find the square root of a complex number. Here we have to find the square roots of 3 minus 4i. So let's start by assuming the square root of 3 minus 4i to be equal to, say, x plus iy. So therefore on squaring we will get 3 minus 4i is equal to x square minus y square plus I into 2xy. So therefore on comparing real and imaginary parts, as we have seen earlier, we have x square minus y square to be equal to 3. Let's call this as equation 1. And 2xy is equal to minus 4, which is nothing but xy is equal to minus 2. Let's call this as equation 2. So now we have to solve these two equations simultaneously. For that, from this equation 2, let us obtain the value of y in terms of x, which is minus 2 by x, and let us substitute this value of y in the first equation, so that we will have an equation entirely in x, which gives us x square minus, now y square, since y is minus 2 by x, so therefore y square is 4 upon x square is equal to 3. Now here if we temporarily consider x square as another variable, say m, so we will have another equation which is m minus 4 upon m equal to 3. So that gives us m square minus 3m minus 4 equal to 0. So on factorizing we have m minus 4 and m plus 1 equal to 0, which gives us m is equal to either 4 or minus 1. But m was nothing but x square, which we had assumed, so x square must be equal to 4 or minus 1. Now here if we see, x was originally the real part of the required square root. And since x is real, definitely x square cannot be negative. So therefore x square equal to minus 1 is ruled out, and we are left with x square equal to 4. So that gives us x is equal to either plus 2 or x is equal to minus 2. Now corresponding to x equal to 2, the second equation gives us y to be equal to minus 2 upon 2, which is minus 1, or corresponding to the other value of x minus 2, we get y as equal to 1. So therefore basically we get these two pairs of values of x and y. So hence the square root is nothing but either 2 minus I or minus 2 plus I. So combining these two, we can write together as the square root is plus or minus 2 minus I. So these are the two square roots of the given complex number.